but I want to kind of review how to simplify a radical, because you will have to in this chapter that we're going into. So with that, we're just going to do a bunch of examples. Okay, I have nothing else for you but a bunch of examples for a reminder of how to do this. So we have a product property of square roots. So for any numbers a and b, where a is greater than or equal to 0 and b is greater than or equal to 0, if I have the square root of a times b, I can split that into the square root of a times the square root of b. Okay, so you can split that number into two separate pieces, and that'll help you simplify. So here, our first one, we have the square root of 3 times the square root of 6. I can multiply my radicand, which is the number on the inside of your radical here. I can multiply those two numbers together. So I have 3 times 6 to get the square root of 18. Now, I can simplify the square root of 18. Do you remember splitting 18 into two different square roots, right? Where I can take the square root of one of them and probably not the other. So for this one, I can split the square root of 18 into the square root of 9 times the square root of 2. Okay, and I want to do that because I can take the square root of 9. Okay, so you always want to look for a perfect square within that number to simplify it. So here, taking the square root of 9, I get 3. I can't take the square root of 2 evenly, so I leave it as the square root of 2. So that would be my simplified expression. Questions? First one. I know my numbers are all screwed up on this sheet. I don't know if you noticed that. All right, I want you guys to do this one then. Okay, number 3. Talk to each other in your groups. Simplify number 3. Yeah, that's fine. As I walked around, most people had this one figured out. So we have 5 times 10, so I have the square root of 50. Okay, the square root of 50 can be split into the square root of 25 times the square root of 2. Okay, and again, I want to split it into that because I can take the square root of 25. That is 5. And then again, I have this remaining square root of 2 here. And that would be your simplified answer. Okay, questions on this one? All right, then coming up here. Yeah, I'm going to jump everywhere. Coming up here to number 4. Again, we have a square root times a square root, so we can multiply those together to get the square root of 30. Okay, now with the square root of 30, I can't multiply 4 by anything to get 30, right? Can't multiply 9 by anything to get 30, or 16. Okay, that's what I kind of look for. Okay, can I multiply something by 4, 9, 16, 25, so on? Okay, because those are the ones you want to split it into to take that square root. I can't. So this would just be my simplified answer for the square root of 30 there. All right, looking at 6, this one's a little bit different. You have constants on the outside of your root this time. So when you have those, you do just multiply those together. So I can take 8 times 9 to get 72. And then I can multiply again my radicand inside that root together. So 2 times 6 is 12. Now can I simplify the square root of 12? Yes, I can. Okay, so I'm going to do that off to the side right here. Okay, I have the square root of 12. That can split into the square root of 4 times the square root of 3. Okay, I can take the square root of 4. That's 2. And again, I have that remaining square root of 3. So I'm going to replace this square root of 12 with 2 times the square root of 3 back over here. So we have 72 times 2 square roots of 3. Now when I bring this back in, I do have to then multiply 72 times 2. That's 144. And then we still have the square root of 3. Are you still with me? Yeah? Is this all coming back to you? Good. All right, I want you guys to do this one labeled 5 and this one labeled 8. Okay, so these two. Simplify those two radicals there. Remember, look for 4, 9, 16, 25, 36, stuff like that. All right, what did you split 75 into? And 3. Okay, I can take the square root of 25, that's 5. And we'll leave the square root of 3 because that is irrational. And that would be my simplified answer. And then 40, we can split into the square root of 4 times the square root of 10. Okay, taking the square root of 4, I get 2. And leaving square root of 10. So I can't simplify that one any further. We good? Yeah? All right. Moving on. 7 here. This is a square root in the denominator. We don't want a square root in the denominator. You need to rationalize that denominator. To do that, you need to multiply by a version of 1. Okay? Multiply by a version of 1. So our version of 1 that we use is this number that's in the denominator. Okay, that's the square root of 5. So I'm going to multiply the numerator by the square root of 5 and the denominator by the square root of 5. And you'll see why in a second. Okay, so if I were to plug this into my calculator, it is just 1. Okay, we're multiplying by that 1, so we're not changing the value of the problem. Okay, so you're multiplying by 1, so you're not changing that number. So when we multiply fractions, we multiply straight across. So here I would have 4 times the square root of 5 over, I have square root of 5 times square root of 5. That is the square root of 25, which can be simplified to just 5 in that denominator. Okay, so when we multiply that denominator by itself, your roots just cancel out. Okay, that's called rationalizing the denominator. Okay, you don't want that radical there anymore. And this would be my simplified answer. Questions? We're going to do another one like that. Yeah, number 2 is at the bottom. Not sure why. Just kind of happened. So we're going to do the same process here. So we want to multiply by a version of 1 using the square root of 3 over the square root of 3. Okay, let's multiply straight across to get 12 square roots of 3 over, can I skip a step and just write 3? Are you with me if I do that? Yeah? Okay. Now here, I can simplify this one a little bit further. Okay, I have this 12 over a 3. That's just a fraction. Okay, that's 12 divided by 3, which is what? 4. Okay, so this simplified answer would just be 4 times the square root of 3. So you do have to look for that fraction part there as well. Okay, up here we didn't have that. We have 4 over 5. Okay, we can't simplify that fraction, but 12 over 3 we could to 4. Make sense? Questions? Almost done? All right, I want you guys to do number 10, bottom right-hand corner. Rationalize that denominator. Yes. Mm-hmm. Yep, you can take one then. All right, so 10, multiplying by square root of 3 over square root of 3 to get 2 square roots of 3 over 3. I can't simplify that anymore, so I would just leave it. Most people had that as I walked around. Okay, last one is 9. This one has a variable in it. Okay, so I have the square root of 16a squared. Okay, so I'm just going to split this into the square root of 16 times the square root of a squared, just so it's a little easier to look at. Now I can take the square root of 16, that's just 4, and if I have the square root of a squared, my root and my square cancel. So I'm just left with a. Now with this, you'll learn in Algebra 2 that you do have a domain error with this. This a should be an absolute value. Okay, there's a domain error with it. Don't worry about that for me today, but just as an FYI, you will need to worry about that in Algebra 2 when you get there. Okay? Okay, questions? All right, then